Hopefully you can hear me. Had a little bit of microphone issue there. Welcome to the kickoff of the magnetic IDEX build. I don't think this will be a crazy long stream. I was working on this last night and I had to fix a few things after I found out some more interesting stuff. So I don't know how long the live stream will be today, but I do want to document my process through the whole build. Hey Nick, welcome. Hey DE, welcome. I definitely want to document like the build because you know, there's some nuances and things like that, and if I do a YouTube video on this and people start asking questions and stuff like that, at least I'll have like a live stream I can point them to for more information and stuff like that. I mean, I do plan on selling this once I'm done. It's just one, I don't have room for it, and the project for me will be done. I do plan on making my own magnetic IDEX printer using the inspiration of this, using the principles that like Dimitri from the magnetic IDEX channel kind of used. So the idea for me is to wrap my head around how this works, and that's why I'm converting this printer. Now, for anyone who's unaware, I got this for free. That's the only reason why I'm using a Replicator 2X. I got this for free. There's definitely some drawbacks to that, which I found out last night, and I will go over those with you. Hey Nuno, welcome. Yeah, I'm excited to get started building this thing and start talking about like what I'm doing with it. I've definitely made some changes to the parts. We'll talk about that, things like that, because yeah, there's a lot to unpack here with this magnetic IDEX, and I want to make sure everyone's aware of what I'm doing if they want to convert their own Replicator 2X, because I converted a Replicator 5 like a couple years ago and I made a YouTube video on it, and I still get comments on that video, and I don't have the printer anymore and stuff like that. So I want to document this as much as I possibly can for people who might find this stream or might find the YouTube video that I eventually will make on this printer. I want to have as much information as possible. So this is a Replicator 2X. The parts that Dimitri have designed are meant for a FlashForge Creator Pro, which has a different frame. So initially, I was just going to use the MakerBot side parts, like the side motion parts here, I guess, the Y motion parts. And I was just gonna hot glue like parts to this, like an end stop and stuff like that, because I didn't want to change this. However, you can definitely see that I've completely taken off the gantry from the Replicator 2X here because of a lot of reasons. Yeah, there's a downside that you have to find a FlashForge Creator Pro, or in this case a Replicator. This isn't compatible with these parts. So this has a different frame, and I found out there's some inconsistencies with that, and I've had to customize parts already on this. So I will be converting over, like I'll maybe make like a flying gantry IDEX or something like that with the magnetic IDEX principle. But first we're going to try to figure out how this works. So I decided against using these. There's a couple of reasons for that. One, I don't want to have to like super glue or hot glue a whole bunch of parts to this, and then they're not aligned correctly, they're falling off, you know, whatever it might be. It's just too janky even for me. So I decided, okay, let's use the whole Acula class motion system that Dimitri made, and let's just add it to this frame, right? Because the replicator, the MakerBot replicator is supported. So I was like, all right. So I started printing out all of the parts for it. Another reason why I wanted to use the whole motion system from the magnetic IDEX is because I can tension the belts. there is no belt tensioning on the MakerBot, right? You cannot tension the belts. So I didn't want me to have like really poor prints because all the belts were loose on this printer and then I was hooped. So another reason why I'm ditching the MakerBot parts for the motion system is, again, I want belt tensioning, which Dimitri has made in his magnetic IDEX parts. However, the frame of the MakerBot actually has these bungs on the corners that protrude into the space. So a part like this doesn't fit. You can actually see my Dremel work to try and figure out why this part wasn't fitting. So this is a motor. The magnetic IDEX uses 2 Y motors, one here and one here, on his motion system. So that's an upgrade from the MakerBot. The MakerBot by default had a single motor back here, and then it had a rod in the front to synchronize both sides of the Y axes. Dimitri's motion system has an individual Y motor on each side, which is great, and that's what I'm going to be using. However, the motor pod for this will hit the bung in the back. There's a bunch of bungs and things that stick out on the frame here, so this actually would not bolt onto the frame. If you'll notice here as well, the MakerBot by default does not have 4 bolt holes on each corner. So there's only 2 bolt holes here. There's only 2 bolt holes here. Only one corner had 4. So I had to drill additional holes, and that's what this is here. This is my drill jig. So basically I bolted it to the existing holes, and then I drilled out M3 holes on each corner. Once I did that, I then tried to fit this part here, and I noticed that it didn't fit because this frame has these provisions that won't allow other parts to fit. So I've had to make my own modifications. Luckily, Dimitri does give you the step files for it. So I've made a new motor part here, or I should say I've modified Dimitri's motor part. Essentially what I did was I moved the motor forward 1 millimeter and I cut out all of this. You can see how much I've cut out on the side here, right here. I've cut that all out so it has clearance now. Okay. Same thing goes for the front piece. So Dimitri has a pretty slick tensioning system here using a threads. So if we thread this tensioning nut, we'll call it, onto here, if I can get it started. It's probably easier just to do this. So you can see here, there's basically a threaded nut that pulls this tensioner to tension the belts, which is great. I have belt tensioning now on this. However, this part also does not fit. This wheel here, this tensioning wheel, is too fat and it hits the bung that's in the front. So I just went into the step file and I shaved off about 2 millimeters off of this, and I now have clearance. So today, the idea is we are going to be able to install the whole Y on this side. It'll test all my parts and then I can mirror them over to here and we can install the Y over there. So what I'm going to do is I'm going to just put this right here because we're going to be working on this end of the Replicator 2X and we're going to be installing these parts. The first thing I want to do though is I do want to finish putting heat sets, the 2 additional heat sets here on this part. And I am using the original Moons motors. So one of these was for X and one of these was for Y. Both of these are going to be for Y in the back here. I'm going to have to buy a small pancake motor for the actual X axes. So this basically goes right here on the inside, of course. And there's a small 20 millimeter kind of NEMA 17 motor, pancake motor that goes here to actually move X. So I'm going to have to buy that. I don't have one, of course, with this printer, but we're going to use the existing Z, and then, of course, we are using some NEMA 14 motors for the actual extruder and hot end, which we'll talk about here near the end. So I'm going to grab my soldering iron here so we can get some heat sets installed. And if anyone has any questions, feel free to ask away. Like I say, I want to make sure that everyone kind of at least has an idea how this works, and I want to explain the reasoning behind like the changes I'm making and stuff like that. I thought initially I was just going to use the tool head and use the existing parts, right? Just take this tool head, pop it onto the X, and then I'll have both of my tool heads here and I can just use magnetic IDEX. But this project definitely has developed into a bit more of a full-blown project, and it's not just an easy, oh, grab the tool heads, put them on this printer. That probably would work okay on a flash forge, maybe, but again, I highly recommend just doing the whole Acula class motion system that's on printables and converting over your MakerBot. Like I say, I will be making a printables page for these files, a remix, so that people can do the same modifications to their replicator that I've done. It's not too in-depth. Like I say, I just drilled out additional holes on 3 of the corners and went from there, kind of thing. So, and I just have 2 heat sets to do, and then we can start mounting parts to this guy. And most of the modifications I'm making are relatively straightforward. I also changed the heat sets here. Dimitri uses a slightly different heat sets. So I changed it to the standard Voron common one that I use, that Voron uses, the 5x4 heat sets. So I've also changed that as well, just because that's what I had laying around. Yeah, I think a lot of people are in the same boat, Nuno, and I think what I'll do is I'll probably make one of my printers magnetic IDEX from the ground up. I was going to kind of make my own open source version of this replicator, but I kind of decided against that. I'd much rather have kind of a better base for a printer. So probably one of my printers going forward will be magnetic IDEX from the ground up. These heat sets in all the way here. Like a 2020 version of this printer would be cool for sure, but I think it's just better for me to design something from the ground up that will make the design easier and a bit more approachable. This is not on. Why did this turn off? But I think the unfortunate thing for the IDEX printer is, or magnetic IDEX, is it's based on this existing design. And you kind of have to get lucky on your marketplace to find a Creator Pro or on eBay or something like that. And sometimes shipping on eBay and whatnot is really expensive, right? So it increases the cost of the build quite a bit for a lot of people who are trying to build it. So I just want to learn like how this works, and then like I say, I'll just do a build, a full ground up conversion or something like that. All right, so we can, for the purposes of this stream, I'm gonna just start assembling this, even though I know I'm gonna most likely have to take everything back apart, because I will be changing out these tensioners here. Use 16 tooth pulleys, which I don't want, and they also use M3 axles or an M3 shaft here, which the bearings on M3 pulleys are not good. You want to try to use M5 pulleys. So I am converting this all over to 20 tooth and M5 pulleys. Yeah, that could be okay for sure. I think I'm just going to do, like I say, kind of like a ground up, more of a square printer, just because things are more common to find in that size and whatnot. Is the benefit of magnetic IDEX you only use one X motor? If you're going to use two X motors, magnetic IDEX does have a benefit. So the real benefit of magnetic IDEX is simplicity. There's no extra belts, there's no extra motor. It's a very, very simple system on how it works. And essentially you just have in the center, you have a magnet on X, and magnet will couple to whichever tool head. So the magnet is basically in the middle, and it will go to one side, couple to this, and then you'll have your tool head A. And then how it works is it'll move the tool head to the far left hand side, and it touches into like a spring-loaded click, and then the magnet can pull away from the tool head, and then it'll go to tool head B, it'll grab it, start printing, it'll go to the left hand side, it'll click into the spring-loaded catch, pull away, and then it'll come back and get this one. So you have that singular X belt, singular motor. It's the simplest way probably to do IDEX. And that's the benefit of magnetic IDEX, is you just have that very simplistic design, which I do like. So again, we're going to go ahead, and I'm actually going to mount everything to these, to my rails, or to my Y shaft. So I am using the MakerBot bearing bushings. I am using the brass bushings for the Y, right? For the X, I'm going to use IGES. I already have IGES. I'm just trying to use all the parts I possibly can for this build. So I am using the brass bushings on each side of the Y. So we're going to grab this here, and I'm going to just slide this into just like so. And then my new part here, which I modified from the original so that it fits the MakerBot frame, we are just going to slide into here. All right, so there's our right hand Y motion system essentially. And again, now this will actually fit up into here. Before it would not, because of all of the weird things on the frame. So it might take a moment here to kind of slide everything into position and whatnot, but sure that I am, oops, I have the wrong, I've got the wrong part here. I've got the original part that I just wanted to show off. So this, like I say, this part's too thick, so I just cut it down. And luckily that's the only modification I had to do to that one. I just had to cut it down. And once I mount this, we'll talk about the tool head, why it's good as is, and why, again, I'm making something from the ground up. Just because the tool head that's on here works way better for this actual printer itself. All right, so I can, what else is in the way here? Let's see if I can get this going back. Oops. All right. Yeah, I might even have to modify it even more, but we will see if I can thread these in or not. What I wanted. See if I can get the back started here. And of course, I'm not tightening anything down yet because I do need to make sure everything is square and lined up and all that fun stuff here. Okay, so I have, what is this hitting on? This is about 2, there we go. Just gonna get these bolts kind of started here. There we go. Okay, so like I say, everything kind of just fits here. Just gonna get everything set in here kind of loosely. Basically, I want to push everything over to one side and lock it in as much as I possibly can, so that this y-axis is nice and parallel and doesn't give me any issues. All right. So that's looking pretty good there. And I will, of course, have to order a bunch more bolts for this, but... Hey, Cindy, welcome. Welcome, welcome. Just trying to assemble as much of the Y as I can today. And I finally have all the parts modified enough so that this all bolts in, as you can see, which is really nice to see. Yeah, looks like I have just enough, or mostly just enough to bolt everything in here. All right, so you probably can't see this, but I have enough room here to actually spin the tensioning nut on the front, so I can tension my Y belt. Again, very, very useful that you can tension the Y belts. On the MakerBot, you cannot do that. And you'll see here the actual Y-axis part. So not only can you actually take this off, right? Like you can't take the MakerBot off as easy as you can this one. you can just pop the bearings out of this and this will come off without disassembling the whole Y axis on this side, which is nice. Our pancake motor will still go into here. And then on the other side, we have tensioning for the X as well. So I'm going to just kind of lock these in. I'm sure I'm going to have to do some tramming once this is all assembled and I'm moving my X back and forth. We'll have to tram everything up. But this is a rigid steel frame, which is kind of nice. But you do have to work around the MakerBot kind of frame, unfortunately. So there's our Y motion on the Replicator 2X. So as intended, we have our existing brass bushings here. We have the proper clearance, and I can actually go ahead and attach my belt at the top of this, and I can tension it at the front. So that's all great. I'm happy all my drilled holes worked out and all my new parts work. So all I have to do is I have to mirror these parts that I modified, mirror them over to this side in the CAD, and then I can start assembling this side. And we will have a fully done Y axes with 2 Y motors. I don't know how I'm going to do the Y motors, if I'm going to make them independent or I'm going to just run them off the same driver with a Y cable. I don't really see why they would need to be independent. I'm not going to do any sort of like tramming in software, so I might just save a driver and just run these all off of one. Speaking of drivers, the main board I'm using for this is a Monster MKS Monster 8, because that's what I have, and it has 2 outputs for heaters. So let's take the frame down and let me actually talk about the tool heads for this printer, because I learned a lot as I was designing or modifying the parts for the tool head. Let me just see if I can raise my camera up here just a smidge. Actually, maybe even move it over just a hair. Okay, that's pretty good. All right, so Dimitri did a really good job on like making everything fit together really well and compact. So initially what I wanted to do was I wanted to take the tool head and I wanted to kind of make it more standard, which is great and all, but it would have wound up being more clunky and not fitting the actual IDEX build for this. If you look at this design, he has the hot end sits up way up high right under the BMG gears, right? Unlike a normal extruder that would actually sit on top and way up high, he has the extruder going back and then to the back of the hot end. So you can see how nice and compact that is. Right? This is a really nice, small, compact form factor, and I don't want to change that, so I'm not modifying the parts for that. I did modify the parts to use a rigid mount hot end. I do not like groove mount hot ends, and the groove mount is what is like by default on this. So I did modify this to fit a rigid mount bamboo style hot end that I got off AliExpress. My printables remix for these parts will have its own bill of materials, which will have the hot end and all the kind of parts that I used. And then the BMG gears, they just go on either side of the tool head. So if you pop these two together, you have this really nice compact tool head, and the CPAP also cools the hot end. So if you look here, there's a little slot in the front. That's where the CPAP will also cool the hot end as well. So the CPAP is for layer cooling, and it's also cooling the hot end at the same time. So again, just to make things more compact and efficient, that's what Dimitri has done, and that's what I'm going to keep going forward on this particular build. So like I say, I had to also modify, I think this is only for a 20 millimeter NEMA 14, and this is 22 millimeters. Luckily, I was able to shave enough plastic so that this just barely fit in here. Again, I'm using the parts that I have available. I've already spent like well over $150 on this conversion, and that's just in hot ends and extruders. So again, I wanted to use the parts that I already had lying around as much as possible. So we also have this filament guide here that can be a little bit tricky to get in. I'll try to show it if I can line it up here successfully. So there's a little blue filament guide you can see that goes up in there as well. And basically what we do is we just pop in these two halves like so. And how this works is there's one 30 millimeter M3 bolt on the back. So we just put that in. It just threads into plastic. There's no heat sets on this. Pretty straightforward for this part here. So I left most of the tool head design alone. I wanted, like initially, before I seen the parts, I wanted to basically just make it with a flat top on the tool head so that you could put a Sherpa Mini on here. You could put like a Clockwork 2. You could put whatever extruder you wanted on the top. But that's going to put a lot of the weight on the top of the tool head, and it's going to affect a whole bunch of different things. And I like how the weight is down and to the back a little bit. I think this looks better, and I think it'll actually perform better. So M3 bolt is how the back actually clamps the two halves together. And then there's this coolant manifold here, which has your CPAP hoses in it, one for the hot end and one for layer cooling. This actually just acts like a collar, and it kind of goes on the front here, and it slides into place, and it holds the front part of the tool head together. So you actually have your cable channel here, so you can run your hot end cables. And then you have your two ports here, one for hot end cooling and one for cooling of the layers. And there's an extra piece that slides on here, and there's kind of some ring cooling for this. I will have to move that down a little bit. This hot end is a little bit lower than the stock hot end. I'll lose like 5 millimeters of Z. Nothing crazy. So for the rest of the actual BMG gears, so we need to put in our extruder gear here. Basically that slides in on the side, on this little opening on the side here. So we kind of want to try and drop it into place. And then there's a little slider that goes in. And there's this threaded like T60 nut that Dimitri designed that tensions your filament path. And there's a little tool here that he made to actually be able to tension the gears. So this just puts pressure on the one side of the BMG gears, and it works very well. I'm just going to put it in here now because I don't want to lose any parts. So you can see there the filament path is really nice. Very easy to get filament in there. And this rotates really, really nice. Like nice and smooth. There's no wobbling or anything like that. Really, really nice. I probably even have this tighter than I need to. But yeah, it's just a really nice, clean setup. So that's one tool head fully assembled. Very small, very compact. And I think it's going to look really nice on this printer, and I think it's going to perform even better. So you can see here, this is where the magnet goes on this here. So essentially what happens is your magnetic coupler will go over and it'll click onto this and it'll attach to the X motor. So you can do your printing and all that kind of stuff. and then it goes to the other side, you'll see that there's a square here. There's a part that actually goes into here, and it has like a prong, and it will go into a spring-loaded clip that you can buy on Amazon. So the clip, how it works is when you press into it, it locks the first time, and then if you press into it again, it'll detach. So it's a really elegant, very, very simple solution on how the magnet can attach to this, and it can detach itself to go to the other side to grab the other tool head. So that's kind of how the tool head assembles, and that's how the magnetic IDEX parts essentially work by default. You have that one center that goes back and forth and detaches and attaches. So I still have to order those clips. Luckily, they are available on Amazon. And I think you get a pack of 20 of them for a couple dollars. They're very cheap, right? They're just a plastic spring-loaded clip that latches once and unlatches on the next press. So, hey, Curl Fox, welcome. Thank you very much. The stream's probably going to only be like another 10 minutes longer. I just, like I say, I wanted to get episode 1 out for you guys. I wanted to talk about the printer and kind of tell you the progress that I've been made, the progress that I have made. I think I've got all the parts. I've got the CPAP hoses. I've got the CPAP motor and all that kind of stuff on the table in front of me. I've got both hot ends. I've got both extruders. It's definitely more work than I initially had planned, for sure. I thought this was just going to be a quick mod to this, but there's still a lot to learn. Like, I don't know how the config and macros and stuff are set up yet, but at least I'm to the point where my y-axis is attached, and I can attach the other y-axes now, and I can start getting the motion system assembled. And then we can mount the Monster 8 probably underneath, or maybe I'll mount it on the back like I usually do. We're going to just cut off the end here. So I am using the existing power supply. So this is a 24 volt, 9 amp power supply. This was designed to run the heated bed, run all the motion. It'll be perfectly usable for that. I'm literally just going to cut the end off of it, grab the positive and negative 12 volt leads, and I'm going to attach them to the Monster 8. Really, really simple. I don't have to worry about 110 volt wiring or anything like that. It's the best way to convert this printer over, and I did verify that this power supply works on our first stream. So really easy modification, and we can reuse as many parts as possible. And then the idea is I'm going to be probably unbolting this screen, and I'll probably make my own similar rectangular box here for like a touch screen for Clipper, just so this kind of has a similar look to what it normally would have had. And then we can have all our functionality on here. I think it'll look really cool, and it'll just be a fun touch to have on this printer. But I have to like pull off, I still have a bunch of wiring here. Some of this wiring I can't use. Okay, so this is for the LED bar on here, which we will keep. So I will try to keep this where it is, this actual wire for the LEDs. And like I say, you can probably see the tensioning nut. Maybe you can't, but this red wheel here will allow me to actually tension my belt. So there'll be a tensioner on both sides on the front here. And then I'm going to use the rods that came with the MakerBot, of course, for the X. I'm going to use IDEX bearings, though, for the X. And I'm going to reuse the bushings for the Y, as I said before. The Z is all, of course, staying the same. There's nothing wrong with this. It's a cantilever design, but there's no point in changing it. Again, I'm still trying to convert this as easy as I can. These parts were not made for a replicator, and they don't work out of the box with this frame, but I will make a printables page for anyone who maybe has a Replicator 2 or 2X so that they can do that. We are also going to convert the end stops all to optical end stops. Homing is very, very important, the accuracy of homing on an IDEX machine. So we want to use optical end stops and not mechanical. So there's going to be an optical end stop, I believe, on this side. And then there's an optical end stop that's going to go in the back so that this will home accurately all the time. I might change how the end stop for Z works. Right now it's at the back here, which I don't really like. I might put the end stop down below if I can easily do that. And then that way in software we can control our Z offset versus the Z offset being controlled by, like, normally you would slide this up and down, or I think there's some set screws here that are kind of buried in gunk that you would adjust to change the trigger height of this. Probably could see here. I think this goes all the way up and it touches this. Yeah. So there's a set screw up here that sets your Z offset. So the better way to do it is actually have your end stop on the bottom, and then in Clipper in your config file, you set your Z offset with the end stop position so that I can just tweak it on the fly versus coming in here, changing this screw, seeing if the first layer is good, changing the screw again, seeing if the first layer is good. It's way better to control it in software. So if I can, I will try to make some sort of optical mount on the bottom here. That might be a bit ghetto. Maybe we won't do that depending on how lazy I am or not. Like I say, I kind of wanted this to be a quick project, and it's not really developing into that quick of a project. But yeah, does anyone have any questions about the initial build of this machine and what we're kind of doing here? Like I say, I'm trying to use all Dimitri's parts as much as I can. Unfortunately, they're not compatible with the MakerBot frame. So I did have to make some very small modifications, but I will put a remix up on printables. And another disadvantage too is, like, a 2020 version of this printer would be a little bit difficult to do in the fact on how these parts would mount. Like, they mount to this frame from the bottom with bolts being up in the top. In a 2020 frame, all the parts would be completely different. Like, we would have to make all the parts from the ground up essentially to bolt to a 2020 extrusion. And if I'm doing that, I might as well make my own printer instead of, like, just making an open source version of this. I might as well design my own printer. And with how lightweight the tool head is on this and how the motion system, I honestly don't even think there's much point of having a Core XY version of this. I really like the much simpler straight belts, right? So this has very nice straight belts for X, a very nice straight belt for Y. And Y, which is the heaviest axis on this printer, is going to have two motors, right? So we have plenty of torque to move this Y really quickly, and the motor that's going to be on X is half the size of this. So X is still going to be quite lightweight, and we'll still be able to actually move this X very quickly. Honestly, the added complexity of adding Core XY to something like this, I don't think there's a point to it, and I'm kind of over Core XY to begin with, so. Yeah, I know, Nuno, I'm the same. It'll be more clear once we have Clipper on here and I show you the macros and stuff like that. I think it'll make more sense, but yeah, it's essentially just a little tiny magnet in the center that attaches to either tool head, and it'll be much easier to figure out once we have everything in place. And I can show off up close. I'm also going to, of course, make a YouTube video on this printer once it's printing, so I can show off how it actually works, how magnetic IDEX works in the different modes and things like that. So, yeah, it's going to be pretty fun to design. I still don't understand how like duplicate mode works. Um, as far as I can tell, you have to have two magnet parts that you can attach. So you add in another magnetic part on the belt so that it can actually couple both tool heads at once. And then you do your duplication and you take the one magnet coupler off, as far as I know. But for the most part, a two tool head IDEX system, it's, in my opinion, it's not really great for multicolor. You only get two colors, who cares? It's for having supports with a different material. So the support can be PETG, which doesn't stick to PLA, and then you can have your normal part as PLA. You'll get really, really nice supports doing that. If your supports are PETG and your parts PLA, I think that's going to be a really big benefit to magnetic IDEX. Yeah, you could do two colors for sure, but I think you really want four tool heads to make it worthwhile for multicolor printing. And I do prefer like IDEX solution or a tool changer solution for multicolor. I think it's way faster than AMS. It's way faster than a multi-material system like that. I think tool changing is the best because all your hot ends can be like primed at the proper temperature. They do a small purge and they start printing. It's not this long filament change and stuff like that. So it's much more faster and much more efficient than an AMS system would be. But yeah, I'm very excited. I think we're making really great progress now that I actually can get the IDEX parts on this frame. We can reuse this nice frame. Last night I thought this whole thing was going to be scrapped because I didn't think that I would be able to get the parts to fit in here because of these weird provisions. But I was able to fit this side, so this side should fit on, and if that's the case, all the rest will fall into place. So that's kind of episode 1 stream that I had for all of you. Like I say, we got our Y assembled. Next stream, we're going to add the Y and we're going to add the X with the bearings, and we are going to mount the tool head, at least one of them. I think what I'll do to begin with is I'm going to put one tool head in here first. We'll get clipper on this. We'll get it printing with a single tool head, and then we'll figure out the IDEX parts and the IDEX docking and all that kind of stuff. There's still a lot of work. There's going to be like 3 or 4 streams, I'm sure, of this before we get it like printing 2 colors or whatever we end up doing. But I think this is a good start, and I think this printer is going to be really neat. And then I can go ahead and start building my own IDEX stuff with inspiration from Dimitri, with the creator that made all of this IDEX stuff. So thanks everyone for coming by, watching episode 1. Like I say, we did get our Y all working properly. I can tension the belt. I do need to order belts for this as well. I'm not reusing the pulleys or the belts from this because the pulleys are not, I don't know what tooth profile they are. I don't think they're GT2. So I'm going to use my own pulleys and idlers. So I just got to order some belts off Amazon. Those will be here really quickly. And then we should be good to go ahead and bolt on the other Y, getting the motion system kind of working. So maybe next stream I'll try to pre-mount the monster board on this, and we'll kind of go from there and see how everything works. So I'm going to end it here, guys. Thanks everyone for watching, and stay tuned for my next stream. Hopefully it will be Saturday, this Saturday coming, the next Saturday. I don't know how busy I will be this week to get all of these parts printed for this side. like I say, I need to make sure everything is working correctly, and I need to make sure I've got all the pulleys and parts and stuff like that. So thanks everyone, and I will catch you all on Discord. And stay tuned for my YouTube channel for more videos I have coming out on this. And I have a Cappy video coming up and stuff like that. So thanks everyone. I'll catch you all later.